Isometric contraction is so good for your fascia and just generally for all of your connective tissue, ligaments, tendons, skin, etc. I'm so happy somebody made this comment. Let's talk about why. Okay, so to understand why isometric contraction is so good for you, you have to understand that collagen is the building block of all of your connective tissue. It is the scaffolding per se, okay? Your connective tissue, aka your fascia, your tendons, your ligaments, etc., is made up of cross-linked collagen fibers, okay? So imagine like these ropes that are all going in one direction, and then you kind of have like little itty-bitty mini ropes that are like linking them in the other direction, but they're mainly going in one direction, and then the cross-linking is basically just for like added strength, okay? And that's important. So all of these ropes should be traveling in the direction of the most common line of force that this tissue gets put under. So let me give you an example. Your ACL, for example, is a ligament, right? Your ACL connects your tibia, which is the bone of the lower leg, to your femur, which is the main bone of the upper leg, okay? And what it is doing, it is resisting the movement of your tibia in front of your femur, okay? So the collagen fibers of the ACL are organized in that direction, in the direction of the main tension, which in this case is actually resisting a movement, right? So the collagen fibers are mainly oriented towards that direction. And what does it do? It makes that tissue as functional as possible, as strong as possible, okay? So how does that happen, and why does isometric contraction make it better? So fibroblasts are these cells that basically produce collagen in your connective tissue, okay? And they exist in that layer in between the fascia, the loose connective tissue. If you watch my fascia video, it's the white pithy stuff in between the orange segments, okay, in that metaphor. So these cells, fibroblasts, have these proteins on the outside called mechanoreceptors, and these are receptors that detect force, okay? So basically what they do is they detect the force that the tissue is being pulled in. And what do? They do something really interesting, okay? They basically build these things called stress fibers inside of the cell, okay? And the reason why they do that is to maintain the tension inside of the cell. So imagine that you have a tent, right? And like the outside of the tent, like the flaps and stuff, are the cell membrane, right? They're like fluid. And then you have the poles of the tent, and the poles of the tent are really what makes the tent stay up. These stress fibers are essentially the poles of your cellular tent, okay? So we're talking inside of the cell that makes collagen, okay? Called a fibroblast. So stay with me here, when the cell detects mechanical force in a certain direction, the cell will start building these tent fibers, these stress fibers, to maintain the inside tension of the cell, okay? And when the inside tension of the cell is maintained well, aka all the stress fibers are going in the same direction, and that direction is the same direction as the main direction of force in the tissue, okay? When these stress fibers are built well, what it does is it stimulates that cell to build, okay? It's called anabolic, like an anabolic state, a state of building, okay? So that means for cells that produce collagen, that cell will then be stimulated to produce more collagen. So the cell produces collagen, and then the collagen basically exits the cell, and it gets aligned into these ropes that we were talking about earlier that are called fibrils. And the direction of the ropes is also guided by the direction of the mechanical force in the tissue, okay? So the collagens align. Like I said, the main rope is along the main line of force, okay? And that helps to make it as functional as possible. It works much better. So what happens when the forces are all jumbled and there's no main line of force, right? The stress fibers don't build in the same direction inside of the cell, right? The poles are crossing and going all over the place. Well, what does that signal to the cell? The cell is like, so this is an unstable environment for me. So actually, instead of building, I'm gonna break stuff down. So what it does is it activates these genes that produce enzymes, and the enzymes basically get released from the cell and start digesting everything around it. The collagen, the tissue, all of the components around it, okay? So the cell can either create or destroy its environment depending on how stable the stress fibers are that are related to the mechanical signal, the direction of tension, okay? So what does this mean for movement versus isometric contraction, okay? So isometric contraction basically gives a very clear sustained signal of a direction, right? Because you're not actually moving, but there's still force being applied to the muscles and the tissues. And without that movement, the force has a very clear direction that's not being changed periodically, okay? The joint angle stays the same because you're not moving. The tissue length stays the same because, again, you're not moving. So what does that do? It creates the optimal conditions for your cells to build collagen. And that collagen then has the optimal conditions to be organized in a way that makes it super strong. And that allows you to have super strong connective tissue, aka super healthy fascia, super healthy ligaments, super healthy tendons, so super healthy joints, right? Super healthy musculoskeletal system in general. So when you're moving, it's like, imagine that you're trying to make a mold in concrete, and the isometric contraction is like you put the thing in the mold and you let it stay absolutely still until it's hardened. The movement is like you take the thing and you put it in the mold, and then like every 10 seconds you like nudge it 2 millimeters, right? Like it's not that much, but over time it's not going to be as good as the one that was just stayed still, right? That's the difference between building collagen during isometric contraction or building collagen during movement. Collagen is still stimulated to be built during movement, but because the joint angle and the tissue angle is constantly changing, that means that it's the arrangement of the collagen fibers are not all in the same direction, and so that tissue is just a little bit less functional. It's not bad in a non-hypermobile body. The issue comes in hypermobile bodies, okay? So in a hypermobile body, your joint is already unstable. That means that when you are supposedly still, there are micro movements happening in your joint because your body is trying to stabilize it, because the joint is moving too much, okay? So you're still, but your joint is not still. That means that the signal of tension is constantly shifting all the time. So that means that the stress fibers in the cell, the poles of the tent, right, are always being built in many different directions. What does that tell the cell? That tells the cell this is an unstable environment and I can't produce collagen. I actually need to go and digest all of the collagen around me. What does that do? It makes really weak connective tissue, really weak ligaments and tendons, really weak joints. Really weak joints are unstable. So then your joints are more unstable. And then that signals the exact same pathway again and again and again, and it goes in a cycle. So the reason why isometric contraction is specifically amazing for hypermobile bodies is because it interrupts that cycle. It actually gives a clear direction for your cells to build collagen in a way that will make your connective tissue stronger in the future. That stronger connective tissue then signals safety to the cells that it can continue generating collagen and keep making your connective tissue stronger. So you can actually improve your hypermobility by doing isometric contraction, which is crazy. Also, just to note, this does not negate the perpendicular shearing motion of the gentle myofascial release that I talked about in another video. For those of you who came from that other video, the hyaluronic acid stimulation is still super necessary for your fascial layers to move. This does not change that. This basically helps your collagen be stronger. So it's one part of the puzzle, and then the hydration of the fascia is the second part of the puzzle. So these two together are like maximum connective tissue health, therefore hopefully maximum joint health. So I hope that this made sense to you guys. Again, thank you so much to the person who left this comment. Absolutely amazing. Sending so much love. Bye!